All right, we'll get this started. Welcome everyone to our webinar. Thank you guys for joining. Today's topic is increased assembly speed and efficiency with NX WAVE tools. My name is Mason. I am the business development engineer from AT Engineering. I am based in our San Diego headquarters. I'm very happy to be joined by Jesse Belden, one of our NX experts in ATA for this topic. Before we dive into the actual content and presentation, just some housekeeping notes. All attendees will be muted through the webinar. If you have any questions, you can type them into the chat. I encourage you to put it in the Q&A, and we'll have Jesse answer them at the end of the presentation. As with the previous one, this webinar will be recorded and will be available on our website and on our YouTube channel. Before I hand it to Jesse, just want to give a quick overview of ATA, who we are, and how we might be able to support your team. So most people recognize ATA as a engineering service company. That's about 70% of our business. We have over 25 years of experience being the technical partner, providing customer with on-demand expertise, including program engineering support to help them meet their mission requirements. We really focus on helping customers solve the high value engineering problems. And majority of our business are in the aerospace and defense segment, which is about 70%. But we also work on other industries, as you can see over here. About who we are, AT Engineering is an employee-owned small business with a full-time staff just around 220 people. And most of that 220 people have a advanced engineering degree, as you can see on the right. We have 9 regional offices across the US, and have mentioned before, we have tons of experience focusing on design and analysis and tests, providing high value engineering services and great quality. This includes everything from, you name it, structure design, structure dynamics, thermal, vibration, vibroacoustics, CFD, and more. And test-wise, we are the leading independent modal test group in the US. We have lots and lots of experience flying our team to the article location and conduct GVT and use that information to help drive the model design. So that's about 70% of what ATA does. It is the service business. And aside from that, this is how most of you, joining the webinar today knows about ATA. We are a Siemens Platinum VAR, value-added reseller who do not only sell the product, we really provide software support and training to our customer. We really focus on the product and solution that we use internally, primarily on design, analysis, and tests. For example, NXCAD, which is today's topic, VMAPS, Star CCM Plus, simulation. For test, we are one of the Siemens partner in the US that can provide, sim-centered test equipments and software. And I think what really sets ATA apart from other reseller is that we sell what we use. Our customer really appreciate, our deep understanding of the tools, and it really shows up when you call our hotline. Every time you call the hotline, you're speaking with a engineer who probably already have VMAP or Nastran or NX up in their screen and use it every day and really understand the problem. Additionally, we teach a variety of classes, primarily dealing with simulation. We generate all the Siemens training material for Nastran. We have 8 and 9 PhDs that supporting Star CCM Plus software. A lot of time when you go online to Siemens website, you want to find a Nastran class, you would either see it in Denver or in San Diego because that's where we teach them. And Siemens is just taking the registration. All right, I want to encourage people to visit our ATA website. You can find all kinds of information up there, including the hotline support information, which is one of the unique perks, getting your Siemens software from ATA. Free resources, including past webinars, VMAP APIs, white papers. You can find it up there for free, and you will be able to download. All right, with that being said, I just want to give it to Jessie, and she will present the NX Wave tool and how we use it, how it might matter for your team. And with that, I'm going to stop sharing and have Jessie take over.
Sounds good. Thank you, Mason. As Mason mentioned, my name is Jesse. I'm one of the engineers here at ATA. I'm also our certified NX expert for Siemens software. So I'm just going to talk to you a little bit today about increasing assembly speed and efficiency with the NX WAVE toolkit. So these are just some of the tools that are built into NX to help you and your team stay in a collaborative environment while keeping things moving at a fast pace. First up, just to give you a brief overview of what we're looking at, I'm gonna go through a few slides that are just touching on the concepts of some of the wave tools. We're not gonna go through every single wave tool, but hit on some of the highlights, mainly talking about the tools that you can access through the assembly navigator, and then taking a look at in our inner part linking tools, we've got the associativity manager, wave geometry linker, and then the product interface and the wave interface linker, which kind of go hand in hand. Those are technically two separate tools, but they play with one another. So that's why we're going to talk about them together. And then after we get over a little brief overview of the slides, we're going to go into the meat of this, which is a live demo, walking through. I'll have my NX session open and walk you guys through some of the ways that you can use these tools and what that might look like if you're building assemblies or part structures. As Maisha mentioned at the end, we are happy to answer any questions that you have about the Wave Toolkit. If you want to throw them in the chat as you think of them, you can, but we won't get to them till the end, or you can just hold them till the end. It's up to you, either way. But throw them in the chat when we get there. First up, before I start diving into the tools, just to give you a brief overview, I've got this assembly here. This is going to be what I'm going to be stepping through in my demo, but it's a very, very scaled down, simplified model of what would be a pirate ship boat ride. So you'll hear me refer to a few different components. We've got the boat itself, some of the leg structures, the loading platform, the tire drive. If you hear me mention that, that's where that comes from. But starting off, we're going to talk about the tools that you can find within your assembly navigator. So first things first is you do have to enable your wave control option to get into this toolkit here. So within your assembly navigator, you can right click, which I'll show you, and click on the wave toolkit, and then you'll have access to all these different tools here. Some of the more useful ones is this create linked part and create linked mirrored part. So creating a linked part is essentially going to take either the assembly or the part file that you have and make a copy of it. And so that way, especially with the linked mirrored part, that's perfect if you have a right hand and a left hand version. So that way, if you want to be able to make changes to only one and always have the other follow suit, that's a great use of the linked mirrored part. Additionally, what's neat is that if you create a linked mirrored part, it's going to give you a little heads up, a little pop-up every time that you open that mirror part and say, hey, by the way, this is a linked mirrored part. Any changes that you make in this part are not going to populate back down towards the parent. So that's usually a good reminder of, oh, this probably isn't something I should be touching or making changes of, because the intent is to have it as a direct mirror of its parent. Another thing that you can do is copy geometry. So if you want to, a linked part is going to pretty much copy the entire assembly or part structure that you have. Whereas if you want to just say, like, I just want to pull in the boat into its own file, or I just want to pull the legs into its own file, you can do that through the use of copying geometry to either a new part or an existing part. Another thing you can do within the assembly structure is open parent parts. So if you have, let's say your boat knows that it references the tire and it references the leg structure, you can open up those parents fully to make sure that everything's fully loaded and up to date as you're working through it, and make sure you don't have any out-of-date references. Something else I'll touch on a little bit in the demo is the use of a control sketch or control structure, depending on how you want to call it and how you want to organize it. But basically, this is a way to have a very simplified, scaled down model or drawing that is just bare bones, but it has all the key interfaces built into it. And that way, you can split off into subdivisions for the leg support, the boat, the tire, the loading platform, all of these different, let's say, sub teams. Maybe you have a few people working on each. You can divide that work out, but the control sketch is going to make sure that everyone is using the same key dimensions and that all your interfaces are going to match up together. Another tool we have is our associativity manager. This is going to allow you to delay updates to parts or freeze certain parts. So if you want to delay an update, that essentially means, I know there's some parts that are referencing other parts. So like my boat references my legs. But you want to change the legs and see what that might look like without having to worry about if you're going to mess something up on the boat side of things. That's when you would make use of delaying your link updates and delaying your assembly constraints so that you could just trial run things, see how it looks, make sure you're happy with it, and then later you can come back to the associativity manager and push through the updates on either some or all of the parts. Similarly, you can freeze parts, which is going to make sure that they don't update with any changes. And so you can view and edit the frozen status of parts within here as well. Next up is our geometry linker. This is something that I use very prevalently when I'm doing modeling. It is a very common tool in my toolkit. What's also nice about this one is it doesn't need separate tokens to access, depending on your licensing scheme. The other Wave toolkits will need certain tokens, but the geometry linker comes with everyone's NX installed. So this one is very similar to kind of like linking parts and bringing things in. And so what does is allows you to link just geometry between components. So you can reference datums, curves, sketches, faces, bodies, and pull those all in as if you want to reference a face somewhere and pull that dimension so that you don't have to repeat the dimension or so that it always stays linked together. So if you change one, the other comes with it. That's something that the geometry linker is great for. This can also create a mirrored body. It won't be quote unquote a linked mirrored body like our other wave tool was, but this one is, it allows you to select a plane. It allows you to mirror a body across that plane and bring that in. And so this is a case where you would use that if you wanted similar mirrors, but not exact. So let's say you have a left-hand version and you're gonna make a right-hand version of it and add a few extra holes. That's when you'd come into the geometry linker. So you'd mirror the body and then you'd go on to do your other operations. And then we're also going to step through the product interface and the Wave interface linker. And so the product interface is kind of where you define all of your interfaces. So anything that you think other parts will reference. So this is nice for my control sketch. I can come in and define all of my key parameters. What height does my boat sit at? How big is the tire? How thick are the legs? Things like that. And, identify those as key interfaces. And then you would go into your other part that is looking to reference those interfaces, and you would open up the interface linker. And that's where you can I'll grab the plane that this boat sits at. I'll grab the plane of the load platform. I'll grab the face of the central shaft, things like that. And so that's why I say they kind of go hand in hand, is because the product interface defines the interface, and the interface linker allows you to take whatever the product interface has defined and bring it into your part. What's also neat about the product interface tool is that you can set rules for interpart linking and assembly constraints. And what that does is essentially if you want to set your interpart linking or your assembly rules to either suggest to your user that, hey, you really should be using an interface here because it's more robust, or you can actually force the user to use interfaces. With that, I just wanted to give a brief overview. I think at least I learn a lot better by doing, so I'm going to walk you guys through what some of these demos might look like. And so, being able to actually use this toolkit. So the first thing I just wanted to show you real quick was on my boat body. This is something that references other parts. And you can tell all I have right now open in my session is the boat body. And my linked body, you can see I've got this yellow question mark, which says source not found. It doesn't know what body it's referencing here because I don't have it open in my session. It doesn't know if that body's out of date or not. It just knows, hey, at one point or another, I brought in this body, I made these modifications to it, and now this is my part. But it can't, if you wanted to go back and change something, it doesn't know if the boat's been updated since or whatever this body came from has been updated. So we want to make sure that we're coming in and opening anything that is related to that. There's two quick ways to do that. One is to right click and you can say open parent part, and it's going to come through. And previously it had thrown an error because I had a boat wall thickness variable that was coming from my control sketch, but it didn't know what the control sketch was because I didn't have it open here. And so this is just telling me, hey, I found where this expression came from because I've opened the parent part. So I said, great, thank you. And now I've got all of these green check marks. Everything's happy. If I come and update that linked expression, everything else will populate and flow down accordingly. So that's option one. I'm going to close that out and close out all of my parts just to make sure to pretend that I don't have anything else that I'm referencing open. So if I open that back up, now it's going to give me an error saying, hey, I can't find where this control sketch variable is coming from. I'm going to say, okay, I'm back to having my question marks, so things are out of date. I can't find the parents. This is when I can come into my assembly navigator. As I mentioned earlier, some of these tools are built into the wave mode. So you can, right now I have it enabled. So like if there's no check mark here, my wave mode is disabled, so I can't come in and do any of my fancy wave tools. But if I click on that, now I can come in and I have all the wave options. But the opening tool is actually present with or without the wave. And that you can come in and say, you can open the parent part of the linked feature. And so it's going to go through again. It says, hey, I found this variable. Great. And now I'm back to having everything loaded. So that's just two ways showing you of whichever is easier and more understandable for you. That's how you can make sure that you have all your references fully loaded so that you know all of your components are up to date and all your references are up to date. With that, I'm just going to kind of step into what I have here for the actual little model boat. You can see I've got my control sketch set up here. And this is a family of what I have is 3 sketches. It could all be one, but I just chose to do it in chunks. And so this is, like I mentioned, it is very bare bones, bare minimum as to, key dimensions that I have. If you step into the sketch itself, you'll see, I have variables defining what height the boat is at, the diameter of the tire, the thickness of the legs, things like that. And so this is just meant to serve as a basis of information. It's gonna, teams that break off. So if you have a team that breaks off and does the boat, they're still going to need to know the boat height. If you have a team that breaks off and does the legs, they're still going to need to know the boat height. The tire team is going to need to know how to do the boat height, what the boat height is. But not only do they need to know it, you also want it to be able to come back and constantly reference this. So if my customer decides that they want their ride to be shorter, I want to be able to change that in a matter of seconds. So I can come in, change the variables on the control sketch, and then it'll populate that into all of the different sub-assemblies. And so that's the beauty of the control sketch, is that everyone is basing their parts or dimensions off of this starter part. And you can come in and just make references to this one part. So if anything breaks, you're going back to the control sketch. If any of the part links break, you're coming back to the control sketch to look at why that might be. And then something else that I chose to do is just to create some very simple 3D structures. So you can see, the boat's not hollowed out. I have no tread on my tire or even an interface. I have no brackets holding the support legs. This is all just pieced together so that you can get a sense of what you need and maybe pull in the boat if the tire needs the boat too. It all depends on how you want to set things up for your team. But this is the use and the beauty of the control sketch and the control structure. With that being said, I'll show you, just step through here, some of our assembly tools. As I mentioned, you got to make sure your wave mode is turned on. and then I'm going to come in wave. And so this is where I can do that linked part or linked mirrored part. But I want to start a part that's going to be the meat of all the seats that are going into this ride vehicle. And what I'm going to do is I'm going to copy geometry because I don't want to copy all of this control structure, but I just want to copy some of it because it's important to me. So I'm going to say copy geometry to new part. It's going to give you just a pop-up just to say, hey, the linked features are going to be independent of the position of the geometry in the source part, just so that you're aware. You'll say, okay, I'm going to just call this seats. And you can come in and select any kind of, you can select a solid body if I wanted to bring in my legs. You can select, a curve or a sketch or a face. I am going to select datum because for the seats, I have these datum planes here that are places where my seat backs are at. So I'm going to come in and select those. I'm going to select just half of them for now. You see this toggle switch that says at timestamp. And so what that means is if I, let's say if I were to check that and down the line, I update my seats to be further spaced out in the control sketch, my seat part will not update if I have this clicked, because that's essentially going to freeze whatever you're bringing in at the current timestamp. I don't want that to be the case. I want this to actively update as other things update. So I'm going to leave that unchecked and click OK. And so now it created my seats part. It's got those datums pulled in there. And I can come into my full up ride assembly and add those in. So come down off my seats, bring that in, and fix it where it's at. So now that I have just somewhere to start for my seats, I want to start putting them in the boat. But one thing that's critical to me is it's going to lay flush against the bottom of the boat. So I want to make sure that I bring in that geometry exactly, and that if the boat updates, I want my seat to update as well. If I make my seats the active part, I can come in and come under my inner part links, and I can come down to my geometry linker. So this all lives, by the way, in your assemblies tab. You've got your wave geometry linker, and then as you press more, there's more of the toolkit. But with the seats, you can come in and with the geometry linker, I mentioned this, you can bring in points, datum, sketches, faces. This is where you can create a mirrored body, not a linked mirrored body. It is a little confusing, but this is within the geometry linker and not within the assembly tools. But you can choose like what body you want to mirror, what plane you want to mirror it about, things like that, which is really nice. I'm just going to bring in faces because that's all that I need for my seat back, let's say. So I'm going to bring in the face that sits at the bottom of the boat. I'm going to bring in those 3 faces. And again, this has the fix at current timestamp option. I'm going to leave that unchecked because I don't want to do that. I don't want to fix it. There's also this associative checkbox, which you can click or not click depending on your preferences. Associative is similar to timestamp in the sense that it's always going to tie to the parent part. So if you have issue, if your fillet radius starts changing in the parent part, then it's going to flow down to my seats. If I unclick associative, I'm going to bring these faces in still, but there is not going to be any link to the parent part. It's going to be as if I had just modeled those faces within my seats part themselves. There's going to be no reference or traceability back to wherever these faces came from. I'm going to leave that. I'm going to leave it associative because I do want the associativeness of it. If you click OK, it'll bring in that face. So now that I'm still within my seat. My seat is my active part still. So I'm going to come in and just make a sketch of what one of these seat backs might look like. I'm going to pull in, oops, sorry, intersection curve. I'm going to pull in the faces of the seat, the boat bottom. And I'm going to make just a nice little square backing. I'll give it a dimension just so that it stays put. And close out of that. Now we can come in and extrude it. I'll just give it a little, just pretend this is the back of our seat here. But you can see how it perfectly forms to the curve that was at the base of that boat. If I go back to my overall assembly and I decide, well, that's a really hefty radius on the boat here, I would like to reduce it a little bit. I can come into my boat body, make that my active part, and I've got an expression controlling that fillet radius right there. So right now it's 3/4 of an inch, but I want to take it down to 1/4. I'll say okay. And you can see not only did the boat body update, but the seat back did as well. So it now it carries that smaller radius. It extended the bigger flat portion of the boat bottom. And so my seats are nice and set up for me, and I can continue to do that on all the different seat planes. Another neat thing you can do with your seats is, as you can see, I still have the faces in there because that's what I linked, but it's a little annoying that they're visual. So what I can do is create a reference set. And set a new reference set that's just seat back. And I'm just going to select this one body. So now when I come into my assembly, you can see currently if I highlight seats, it's also showing that bottom of the boat. But you can come and replace the reference set to seat back. And now it's just that one solid body that you got there. Some other assembly tools you can come in and take a look at are load inner part data, very similar to all the parent openings we were doing at the beginning, but basically, do you want to load the parent parts for all the parts in the displayed assembly, all the parts in the session, the immediate level, so just the immediate parents or all levels. So I'll go ahead and make sure that everything's loaded so I know everything's up to date. What's also useful is this inner part navigator. So you can come in and take a look at, it's just a visual diagram of what parts are linked to each other. So what, the base bracket has an input from another part, and the load platform has an input from another part. But then you can also see that the boat body feeds information elsewhere. So that's just a nice visual way to look at things if you're trying to track where something's getting information from. You can also change it to be, this is what I prefer, is left to right. But that's just a personal preference kind of thing. But that's just a nice little visual we've got there. Anyway, to continue on with our seats, we're going to come back to our control sketch, and I want to bring in these planes. So these are going to be key performance indicators. These are going to be key product features. So I'm going to want to make sure that my seats are using all of these datums and any other functions that they might need. So this is where we come into our product interface. Within the product interface, you can see I can set an output, an input, a KPI. I can also choose what I want to define as an interface, so a body, a sketch, a datum. If you select expression, it'll give you all the expressions that are tied into your part currently, and you can pull those in. Or you can come, we're going to do a body here. Let's say, I want to make the base here a body. So I come in, you'll see, I just clicked it, it says solid body. They're all going to show up with that generic name at first. So usually I like to come under properties and just rename it to whatever I know it is so that it doesn't get lost in the big row format over here. So now, I've got my base. What you can also do, as I mentioned, is set rules for inner part linking and assembly constraints. So you can allow any. So if you want if your users to be able to, if they're making assembly, can they reference anything that's going on here? Does it have to, are you going to suggest an interface? You can tell them as they're making assembly constraints, hey, here are your interfaces. It would be smart to connect to those. Or do you want to actually restrict it to an interface? So you cannot put assembly constraints on this unless you're using an interface. Those are just more so kind of more like admin selections of how do you want to set this up so that someone is not going to come in and make a mistake, and how much freedom do you want to give to the designing team. But you can see I've got all of my seats already defined as product interfaces, all of my seat backs. So wherever the rows are at, I've got datum planes for all of those. So within my seats, I'm going to come back into my inner part link browser. Oh, sorry, not that one. Coming back to my Wave interface linker. And I'm going to look through all the file names. I'm going to find, I know I want to pull something from the control sketch. So I'll come into the control sketch. I want to pull in my seat rows. And you can see if I were to click seat row -1, it gives me an alert just saying, hey, by the way, you have an extraction of this object, which is all of the, when I did the wave geometry, or when I created the copy geometry to new part as my first step for the seats, and I brought in some of the datum planes, but not all of them. That's what this is warning me of, is that I've already brought in those existing datums to this part. Are you sure you want to create another one? You can. It's just giving you an alert just to make sure, like, hey, this is the best modeling practice is to not have copies of these. Are you sure you want to copy? But so I realized that I already have links of seats, -1 through -5. So I can come down and bring in my 0 to +1 through 5. Same thing as you can dictate whether you want it to be an associative pull or non-associative, and all your display properties, whatever you're inheriting from the parent, you can make selections for that. And you say okay, and now you can see all of my datum planes have been brought into this seat assembly. But that's where we're going to leave the seats for now. You can see we're going to go back to our main ride assembly. And what I'm going to do here is come under my associativity manager. And I'm going to say delay assembly constraint updates and delay link updates, because I'm going to make changes to the control sketch, and I want to make sure that it doesn't populate to this actual assembly, because what if I don't like it? I want to be able to change my mind without potentially messing something up and having geometry errors and things like that. So I'm just going to delay everything to make sure that I like the way it looks in the control sketch before the assembly starts updating. So I'll say okay with that. I'm going to do just a split screen here so that you can see on the control sketch side of things. So in my control sketch, I've got all these different parameters. And right now you can see we've got a pretty tall and skinny boat ride, but let's say our customer changed their mind. They don't have the space for that. Instead, they want to do more of a short and stubby boat ride. So we can come in and change the diameter of that the boat sits at. We'll change the height of the boat, change the length so that it accommodates the new diameter, and then make it a little bit fatter. We'll say okay. And you'll see on the left-hand side, it's going to update. Now I've got that short and stubby geometry. And I like it. I've decided, everything kind of picked up the way that I expected it to. I'm happy with it. Our customer's happy with it. So now I can come back over here, come back to my associativity manager, and take a look. It's going to tell me, hey, you have all of these parts out of date. Let's say I just want to take a look at, well, what my support structure look like. I don't want to update everything just yet, but let's just take a look at the support structure. So I can say update selected parts, and it's going to bring one of my support structures up and give you a brief overview as to what that might look like. And you're like, okay, I'm happy with that. What if we check the boat body? So you can update that one individually and see what that looks like. And let's decide you're happy with the way that everything is looking and you want to push this update to everything. You can just highlight it all and update. And you can see, because these are children of the other parents, they have to be updated on their own. But now my assembly has all the changes that were made in the control sketch. So that's been pushed to all of the detailed parts. So that's kind of all that I've got for the demo here. You can see that it's a really great way. All the wave tools are very beneficial if you have parts that are needing to reference geometry on other parts, or even if you just want to set up a control structure or a sketch so that your team is able to, the tire team can work independently from the boat team, but everyone is still working with the same information, making sure that everyone's information is up to date. And if you're controlling if changes can happen, when they can happen, if you want them pushed out or not, you want to push them out just in your session, or you want to push them out in the entire, across product line.